नमस्ते विद्यार्थी मित्रांनो. कालच्या भागामध्ये आपण लेसन नंबर 8 स्टार्ट केला होता, ट्रान्झिशन अँड इनर ट्रान्झिशन एलिमेंट. त्या लेसनचा पुढचा पार्ट आपण बघणार आहे. आजच्या आपल्या भागामध्ये आपण दोन महत्त्वाचे पॉईंट बघणार आहे, ते म्हणजे आयोनिक रॅडियाई आणि आयोनायझेशन एन्थॅल्पी. याच्याबद्दल ज्या काही कॉन्सेप्ट आहेत त्या कॉन्सेप्ट आपण क्लिअर करून घेणार आहे. लेट अस स्टार्ट. आयोनिक रॅडियाई. विच पॉईंट्स आर रिलेटेड विथ द आयोनिक रॅडियाई? रिलेटेड विथ आयोनिक रॅडियाई फॉर सेम ऑक्सिडेशन स्टेट with increase in nuclear charge there is a decrease in ionic radii. This is very first important point, is that for the same oxidation state with increase in the nuclear charge there is decrease in the ionic radii. So what we are understanding, there is decrease in the ionic radii. Point number first. For example, when we are talking about when there is a decrease in ionic radii, some example we are going to give. For example, chromium plus 2. Okay, chromium present in plus, otherwise chromium having plus 2 charge. That time the ionic radii of chromium measures near about 82 picometer. And when copper having plus 2 charge, that time the ionic radii of copper plus 2, it measures about 72 picometer. By the comparison of these, chromium plus 2 and copper plus 2, here we can observe that the ionic radii decreases. So here it is clear cut proof that, okay, the ionic radii is a decreases. Okay, because in 3D block element, scandium, Satyvikraman, Feconico, zinc, scandium, titanium, vanadium. Okay, in that chromium comes first and copper comes afterward. Point number third, some elements show oxidation state as M1 plus, M plus 2, M plus 3 and M plus 4. This is also one important point regarding with the ionic radii, that some elements are there, they are showing their oxidation state as a M plus 1, M plus 2, M plus 3 and M plus 4. Point number 4, with higher oxidation state, you can observe M plus 3, M plus 4. These are the higher oxidation state. With the higher oxidation state, effective nuclear charge, what happens, increases. When there is a higher oxidation state, when we are considering the higher oxidation state, that time effective nuclear charge increases and there is a decrease in the ionic radii. When there is a higher oxidation state, there is effective nuclear charge, increase effective nuclear charge, and as a result of increase nuclear charge, there is a decrease in the ionic radii. And point number 5, this ionic radii is observed in M plus 2 level up to M plus 3 level. So these are the oxidation state, metal plus 2 level and metal plus 3 level. This ionic radii we can observe in case of M plus 2 level and M plus 2 level up to M plus 3 level. So this is the important point regarding with the ionic radii. But we are going to write the answer as ionic radii. These 4-5 points are important for you. So maybe this question will go for 2 marks. Point number second, ionization enthalpy. So before that, in the previous video we have seen that the energy which is required to remove the electron from the outermost orbit of an atom, that energy is known as ionization energy. Okay, this is a definition we have seen. But today we have to see the ionization enthalpy regarding with the transition element. How we are going to prepare our short note on ionization enthalpy. So let us start. Some 5-6 points are there. Regarding with the ionization enthalpy, the first important point is that ionization enthalpy increases. So this point is a notable point. Ionization enthalpy increases from ionization enthalpy number 1 up to ionization enthalpy number 3. So ionization enthalpies are there, that ionization enthalpies are increases from IE1, ionization enthalpy number 1 up to ionization enthalpy number 3 in the first transition series. So we are knowing that, okay, first transition series is commonly called as 3D series. Point number second, when we are talking about ionization energy increases in the 3D series, that time some example, solid example we have to give. Okay, these are the example related with the 3D series. Okay, in the 3D series, Scandium ionization enthalpy 1, IE1 632 kJ per mole. Ionization enthalpy 2 in scandium 1245 kJ per mole. Ionization enthalpy 3 in scandium 2450 kJ per mole. So from this we can observe that ionization enthalpy values are increased 632, 1002, 1245, 2450 kJ per mole. So from this it is clear that ionization enthalpy values are increased. Point number third, there is a slight, here we are saying that ionization enthalpies are increases, but okay, point number third is little bit important point. There is a slight variation in case of ionization enthalpy values across the transition series. Especially this a slight variation we can observe in case of ionization enthalpy number 1, ionization enthalpy number 2 and ionization enthalpy number 3. So this is the third point. Point number 4, in case of third transition series, 4f orbitals are there. That 4f orbital give poor shielding effect. Pay attention there. This point is regarding with the third transition series. In case of third transition series, what happens? Due to 4f orbital gives poor shielding effect. Okay. Due to that poor shielding effect, what happens? Point number 5. So, due to poor shielding effect, the valence electron, the electrons which are present in the outermost orbit, that is the valence electron get attraction of nuclear forces. The valence electron, the electrons which are present in the outermost orbit, that electrons are called as valence electron. That valence electron get attraction of nuclear forces. Okay, they are get attracted toward the nuclear forces. A greater amount of, point number 6, therefore the greater amount of energy is required. Why? For that, greater amount of energy is required to ionize element of 3D series. Okay. So electrons are pulled toward the nuclear forces. Therefore, the greater amount of energy is required to ionize elements of 3D series. And therefore, there is increase in the ionization enthalpy. So very important 2 points today we have seen. It's a time to stop here today in this video, but tomorrow once again whatever the important points are there regarding with the transition and inner transition element, that we are going to see tomorrow. Thank you. Keep watching AlchemyN.